Hey guys, Mr. B here again, bringing you another awesome math video. This video is on a topic that sort of spans a lot of things, and it's half-life. So you might see this in physics, you could see it in biology, you could also see it in math. Personally, I teach math and physics, and I've taught this topic recently in both of those courses. So it's a topic that, by knowing you can sort of help yourself out in a couple different courses. So really the idea behind half-life, and I've sort of given a graph here of it, is that half-life is a situation where you have a certain amount of a substance. So in this graph, you're given 16 grams of a substance. And the half-life of a substance is how long it takes for that mass to divide by 2, so to go to half its original mass. So if 16 is the original mass, then half of 16 is 8, so all the way down here. And you can see that in that time, 3 hours has passed. So this would be the half-life for whatever substance is graphed here, will be 3 hours. But another thing you can see is that this is an exponential curve. So half-life varies exponentially. It's exponential decay. So depending on what course you're in, you may see the half-life formula look a little bit differently depending on if it's physics, math, or biology. I can speak for the math and physics. I can't really speak about the biology. So for physics, this is the formula that we use in physics. So it's a little bit. Let's get rid of that. So this is the formula that we use in physics. So it looks something like this. So A is equal to AO, and then you have your half-life. Your common ratio is half, and then you have T over T to the 1/2. So I like this formula best, to be honest, because it's pretty straightforward. And usually, in physics, what A stands for is activity. So the activity, it's sort of like a radiation kind of thing. So you got your A, which is how much activity at a given time. Then your AO is your initial activity, and then you have your time. So that's how much time has elapsed, and then this T to the subscript 1/2 is your half-life. In math, I teach it this way. So Y is equal to A C B to the X. So it's a little bit differently. I don't have the over part right here. So what that means is if you have a half-life of, say, 3, then in the equation this B value would actually be 1/3, because your half-life has to be on bottom. This is what I really like about the physics formula. It's you put the numbers in exactly where they go. Whereas this math one, there's certainly a little bit of room for error here with this B value. But again, this has to do, reason why we do this way is because of the mapping rule and all the other things that we know from math courses. And again, you may not see it that way in your course. Again, before the curriculum changed here where I teach, I taught it totally different. Well, it wasn't totally different. It was over B. So instead of having the times B, it was over B. So it really depends. But reality is, there's many different ways to do it. Do it whatever way works for you. So I'm actually going to, in this lesson, I'll do it with this formula, which works, no matter what you do. All right, so let's have a look at a question here. Why does this keep popping up here? Well, it's because I have my really old computer here. But anyway, so let's see. Bernzium-99, a radioactive isotope, is used in nuclear medicine. Has a half-life of 6 hours. Set up an equation and use it to determine how long it would take for 500 milligrams of bernzium-99 to reduce to 100 milligrams. So if you look what we have, this right here, so this is our initial amount. So that's our AO, so let's say that's going to go in front of our 1/2. This is our half-life right here, 6 hours. And this is our how much we actually have. So we're trying to figure out how long it's going to get to that. So let's have a look and see if we can't set this guy up. So again, we'll look at our original A is equal to AO. 1/2 t over t 1/2. So our A in this case is 100 milligrams, so that's how much we have after a certain amount of time. Our AO is 500, and then we got the 1/2, and then T over my half-life, 6. So the only unknown that we actually have in this question is that T up there, which is a little bit tricky to solve for. So one of the common mistakes that I often see students making is taking this 500 and multiplying it by 1/2. It looks so convenient and so inviting, but you cannot do that. So the reason why you cannot do that because of this exponent, t over 6. So instead what we have to do is we have to divide both sides by 500. So in doing that, what we allow ourselves to do is we give ourselves a little bit of an easier question. So this is 0.2. And this 500 divided by 500 is 1. And then this 1/2 t over 6. So once you reach this stage, you have two options. We do not have common bases here, so we cannot try to find a common base. We have to use logs. So in logs, we have two possible scenarios. This is an exponential function, so we can change from exponential form to log form. So by all means, you could do that. So change from exponential to a log. The way I prefer to do it is to take the log of both sides. So take log of both sides. So by doing that, it makes it a lot easier, I think. But again, either way works, whatever way you want to do it. So I'm going to take the log of both sides, so I end up with log of 0.2. You could also do the ln of both sides if you want to. That works for me as well. And then I'm going to go log of this guy, 1 over 2 t over 6. So remember that log of 0.2, that's just a number, so that's just a decimal, so I can work that out eventually. So now I'm going to use one of my rules of logs. So this t over 6 is an exponent, so that can come down in front here. So I get log of 0.2 is equal to t over 6 times log of 1/2. So log of 1/2, that's also just a number, so I'm going to work those out on my calculator here. So log 0.2, so I'm just going to leave this to about 4 decimal places. I want to try and keep my approximation as best as possible. So 6990, and then t over 6, and then I'll go log of 1/2, and then that is negative 0.301, and then another 0. So now I'm going to take this number right here, I'm going to divide it by 2. I'm actually just keeping that number right in my calculator. So I'm left with 0.6990 is equal to negative 0.0502 t. So now in order to get t by itself, I have to divide both sides by negative 0.0502. Just like that. Negative 0.0502. And then I'll just work out that number, and then I'll give you my time. So let's see. 0.6990 divided by 0.0502, and that gives me about 13.9. So that is how much time has elapsed for that substance to decay from 500 milligrams to 100 milligrams. So, great way to check would be to go back to this first step and actually plug in right here would be 13.9. So if you did that, you should get approximately 500, and I'm just going to give it a shot. So 0.5 exponent 13.9 divided by 6. So make sure you use brackets when you do all this stuff, guys. Really important. And then I'm just going to multiply that by 500. And, I get pretty close to 100. I get 100.3. So that's pretty good, for estimating there a little bit using the logs and the decimals and stuff like that. So that's a pretty good answer. So the only thing I would caution if you're a physics student is make sure that you take note of the sig figs. I'm treating this like a math question, so in math generally we don't worry about sig figs, but in physics if we were worried about sig figs, we only got one going on here, so really be careful. So you'd have to think about rounding that answer, which would be a little bit, a bit of a pain in the butt, but it is what it is. So just be aware of that. Alright, so here's another very similar question. So you have a radioactive isotope, has a half-life of 125 years. How long does it take to decay from 200 to 120? So again, I'll write out my initial formula. A is equal to AO 1 over 2 T over T 1 over 2, just like that. A little bit messy. And then we start filling stuff in. So we got, after a certain amount of time, it's 120. And then initially it's 200. And my comm ratio is 1/2. Of course, it's half-life. And then I got T over 125. So this is exactly the same question. But I'm going to do this a little differently this time. I'm going to actually use the other method I mentioned, changing to exponential form. So divide both sides by 200. Just like that. So I'll get the decimal for that. 120 divided by 200.6. Should have known it. 0.6. And that's 1 over 2 T over 125. So again, right now I'm in exponential form. So I can change that to logarithmic form fairly easy. So the base of my exponential is the base of my log. So log of 1/2. What the exponential equals goes inside my log function, so 0.6. And then what is my exponent is what my log equals, so T over 125. So if you have a calculator that can compute this, then really it's not much of an issue. You can just throw that in there and get it. But if you don't, then what you have to realize is that you need a way to do that. My TI-83 cannot compute that. If you have a TI-84, probably can. So what you can do is you can rewrite this. So this is the same as log of 6 over log of 1/2. So that's a really neat formula. So the log of whatever divided by the log of the base. So that's a neat formula to be able to compute the value of a log of any base. And if you do that, log of 6 divided by log of 0.5. Now remember, these are log base 10, so any calculator can do it. You end up with this guy. Negative 2.58. Let's call it 585. So you got negative 2.585 is equal to T over 125. And actually I made a mistake. That should be 0.6. I was wondering, where is this negative coming from? Starting to have a panic attack there. Alright, let me try it again. So for all you guys who started raging at the screen, my apologies. Log 0.6, Poverty's Nerfic, divided by log of 0.5. And then this is a much better number. 0.73697. So I just went to an extra decimal place there because I didn't want to erase. because I forgot I had the round. Alright, so, and I write that in there. 0.73697 times 125. So I'm going to cross multiply here. So all I'm doing is multiplying these two together. So I get T is equal to 92.1. And that's all she wrote. So hopefully, guys, this makes sense. Another thing you should be doing is writing a concluding statement, especially for physics, with the correct number of sig figs. Alright, so hope this video helps you figure out half-life. And if you got any questions, feel free to ask. Thank you guys for watching. Good luck.